We all know that feeling, right? You walk into a room and completely forget why, or you blank on a familiar name and you think, oh, it's just my age. But what if we're too quick to dismiss these little slips? What if there's more to the story?
It's a question many people ponder, and you're not alone. You've been sending us your research, your thoughts, even your personal stories, all searching for a deeper understanding of dementia and Alzheimer's.
And that's exactly why we're here today, for this deep dive. We're cutting through the noise to get to the heart of these conditions. We'll be exploring the connection between dementia and Alzheimer's, looking at causes beyond genetics, and uncovering the latest in prevention and treatment. All of this is sparked by a fascinating conversation with Dr. Didem Öz, a leading expert in the field, featured in a recent YouTube video.
We're on a mission to extract the key insights from Dr. Öz's discussion, giving you clear and practical knowledge without overwhelming you with technical jargon.
So first things first. We hear these terms, dementia and Alzheimer's, used almost interchangeably. Can you help us understand how they're related?
Absolutely. Think of it like this. Infection is a broad term encompassing many different types, right? You could have a skin infection, a urinary tract infection, and so on.
Right, different types under one umbrella.
Exactly. Dementia is like that umbrella term. The word itself literally means losing one's mind. But in medicine, it refers to a range of conditions affecting cognitive abilities. Alzheimer's disease is one specific type of dementia, and importantly, the most prevalent, making up about 60 to 70% of cases.
So if someone asks, is it dementia or Alzheimer's? The answer is Alzheimer's is a form of dementia.
Exactly. But remember, dementia doesn't automatically equal Alzheimer's. Other factors can cause dementia, like vascular problems after COVID, brain tumors in specific areas, even head trauma.
That broadens our understanding of what dementia can be.
It does. And while we can diagnose with a high degree of certainty in living patients, a definitive diagnosis often comes from post-mortem brain examination.
Speaking of examining the brain, how do today's imaging techniques like MRIs fit into the picture? For someone trying to understand these conditions, how helpful are they?
They are incredibly valuable. MRIs and other imaging tools are crucial for diagnosis. Combining those images with clinical observations, symptoms, medical history, cognitive tests helps us achieve a high level of diagnostic accuracy.
So it's not just one test, but a holistic view.
Precisely. It's a culmination of years of careful observation even before modern technology. Doctors meticulously tracked symptoms and studied brains post-mortem, gradually refining the diagnostic criteria we use today.
That foundation is remarkable. You mentioned post-mortem brain examination, which brings us to brain donation. Can you shed light on its importance?
Absolutely. Studying brains after death is crucial for advancing our knowledge. However, the word donation can be misleading. It's not like organ donation for immediate life-saving.
Right, it's a different kind of contribution.
Yes, postmortem brain examination might be a more accurate term, emphasizing its role in research. Examining both diseased and healthy brains allows us to compare and learn. We have to consider genetic and geographic variations too. Brains from different regions, like Spain, America, or Turkey, might have subtle differences due to genetics and brain plasticity.
So studying a diverse range of brains is essential.
Absolutely. This approach helped us develop standardized criteria for Alzheimer's diagnosis and understand its mechanisms. It raises an interesting thought too. Could there be regional predispositions? Studying Turkish brains might reveal unique characteristics or variations in cellular behavior.
Now, to address a question that's likely on everyone's mind, the nature versus nurture debate. What roles do genes and environment play in these conditions?
It's not an either situation. Both genes and environment contribute. Imagine a pre-existing disease course, which environmental factors can then influence, speeding it up, slowing it down, or even altering its path.
So our lifestyle choices can actually make a difference.
Absolutely. This is evident in non-degenerative dementias like those caused by brain injury, carbon monoxide poisoning, or vascular problems from rapid blood pressure drops. The environment has a direct causal role there.
What about Alzheimer's and similar dementias that are more gradual?
Degenerative dementias involve progressive cell loss and dysfunction. They're generally classified as either sporadic, where the cause is largely unknown but likely involves genetic predisposition, or genetic, where specific gene alterations are identified. These genetic changes can be inherited or acquired during life due to things like radiation, stress, or certain medications.
So even with a genetic component, the environment still exerts its influence.
Precisely. One of the big mysteries is why some people with protein buildup in their brains, a hallmark of Alzheimer's, develop dementia while others don't. Aging itself seems to be a crucial factor. Early studies on nuns, for example, showed some had protein deposits, but no cognitive decline. The why remains a puzzle.
It seems the presence of proteins is just one piece of the puzzle.
Right. We're finding that different degenerative dementias involve specific proteins targeting particular brain networks. It's like bacteria having preferences for certain body parts. H. pylori in the stomach causing ulcers, while another bacteria targets the urinary tract. Similarly, different proteins affect different brain networks.
Can you give us an example of these brain networks and their functions?
Of course. We have various interconnected networks in the brain, each with its own job. The frontal lobe at the front of your brain orchestrates planning, decision-making, initiating actions. It's the conductor of the orchestra. Behind it, regions process visual information, and on the sides, areas handle hearing and sounds.
So different parts of the brain for different tasks.
Exactly. These networks are made up of different types of brain cells, too. For instance, networks involved in quick reactions have larger, faster neurons compared to those in memory networks, which are smaller and focus on forming new connections. This difference reflects their distinct roles.
So for something like reacting to danger, you need those quick response neurons.
Exactly, and this individual variation in brain organization explains things like our navigation skills. Some learn new routes easily, others struggle. It's the unique wiring of each brain.
You mentioned the frontal lobe being responsible for initiating actions. Can you give us a concrete example of what happens when that area is affected?
Let's go back to the coffee cup example. Your frontal lobe is what makes you reach for the cup, grasp it, and bring it to your lips. It initiates that action sequence. If that area is damaged, it can cause apathy difficulties starting tasks, even those once enjoyed. They know they should do something, but lack the drive to begin.
That clarifies the frontal lobe's importance. You also mentioned memory networks being more vulnerable. Why is that?
Memory networks are constantly active, taking in new information, forming memories, which requires ongoing protein synthesis and cellular activity. To create a memory, multiple senses are involved. What we see, hear, maybe even smell or touch. These sensory details converge in the hippocampus, a central hub that links them together. The more senses involved, the stronger and more easily recalled the memory. Like vividly remembering your favorite coffee cup, the look, the aroma, the feel creates a more robust memory trace.
So the more ways we experience something, the stronger the memory.
Exactly. It's like creating multiple pathways to the same information, making it easier to access later. This brings us to cognitive reserve, your brain's savings account. The more connections and pathways you build through learning and experience, the more resilient your brain becomes to decline.
That's encouraging. The idea that we can build up this reserve.
Yeah. Absolutely. And a critical factor in memory formation is attention. You can't remember something if you didn't pay attention to it. Attention, largely controlled by the frontal lobe, is like a spotlight, focusing mental resources on what matters. Furthermore, emotions play a powerful role. The amygdala, responsible for processing emotions, adds an emotional tag to memories, making them stronger and easier to retrieve. Think how vividly you remember a surprising or curious moment. Those emotional tags make the memory stand out.
So those emotionally charged moments stick with us longer.
Precisely. To illustrate this multisensory, emotionally tagged encoding, think how you remember someone you just met. You might recall their face, voice, maybe a piece of jewelry they wore, and your overall feeling during the conversation. The more details your brain encodes, the stronger and more lasting the memory.
It's like creating a richer, more detailed mental picture.
Exactly. Beyond memory and attention, we have networks for visuospatial skills, understanding and navigating space, and networks handling simultaneous and sequential processing. Think of a skilled multitasker, like a tailor, taking measurements, calculating costs, assessing design, listening to a conversation, all while explaining their process. That's a complex interplay of different brain networks. The brain's capacity is truly remarkable.
It really is. Now, focusing on Alzheimer's, you mentioned that specific proteins target specific networks. Which networks are primarily affected in Alzheimer's, and what are those proteins?
In Alzheimer's, the memory networks are the primary targets. Imagine brain cells in these networks constantly communicating, like holding hands in a circuit. This communication happens electrically, through ion movement, and chemically, through neurotransmitters and other proteins. It's important to note that the processes leading to Alzheimer's and many neurodegenerative conditions can start years, even decades, before noticeable symptoms. We see this in Parkinson's, where people might experience changes in smell and digestion long before motor symptoms. This is because proteins accumulate in those areas and along the vagus nerve connecting the gut and brain.
So these protein changes can be silent for a very long time.
Exactly. In Alzheimer's, a key player is the amyloid precursor protein, important for cell growth and repair. But in Alzheimer's, it's processed incorrectly. Instead of being cut into soluble fragments that are cleared away, it forms sticky, insoluble clumps called beta amyloid plaques that accumulate outside neurons, creating traffic jams.
So these plaques are physical barriers disrupting communication.
Yes, they interfere with neuronal communication. But there's another protein involved, tau. Tau, found inside neurons, stabilizes microtubules, which act like railroad tracks, transporting nutrients and essential molecules within the cell. In Alzheimer's, tau becomes hyperphosphorylated, meaning it gets too many phosphate groups attached. This causes it to detach from the microtubules and form tangled threads inside the neuron. So the cell is under attack both externally from amyloid plaques and internally from tau tangles, ultimately leading to cell death and breakdown of the memory networks.
A two-pronged attack. What triggers this faulty protein processing in the first place?
That's a major research focus. Genetic factors increase risk in some, but there are likely other triggers and environmental influences. Interestingly, there's even a theory that amyloid might be protective at certain levels, helping us forget painful memories. The problem seems to be an imbalance. Healthy brains forget what's unnecessary. Alzheimer's brains forget what they should remember.
That's a subtle but crucial difference. Where does this protein buildup usually begin in Alzheimer's?
Amyloid buildup often starts in motivation centers and the precuneus, involved in self-awareness and memory recall. Tau tangles tend to first appear in the entorhinal cortex, connected to the hippocampus and crucial for our sense of time and spatial navigation. This might explain why difficulty with timekeeping can be an early Alzheimer's symptom. Importantly, these changes can start years before noticeable symptoms and often don't show on standard MRIs initially.
So silent progression over time.
Precisely. There's also protein seeding, where misfolded proteins can act as templates, causing other proteins to misfold too. It's a chain reaction, speeding up pathology and cell death. This is why different dementias can look similar in later stages. But initially, the protein buildup affects specific networks, making early diagnosis crucial to identify which abilities are first impacted: language, visual perception, or memory. There are even rare cases of early onset Alzheimer's affecting the visual cortex, causing visual processing problems despite healthy eyes. Imagine someone not recognizing a tomato in their refrigerator.
That highlights how Alzheimer's affects more than just memory.
Exactly. And the loss of smell in Alzheimer's is another example of its impact beyond memory.
To better understand memory and its disruption in dementia, can we revisit the library analogy?
Certainly. Imagine your brain as a library with countless books, each representing a piece of information or experience. Your frontal lobe, with its attention function, acts as a flashlight, allowing you to focus on specific sections or books. Encoding a memory is like cataloging a new book, labeling it with emotions, associations, sensory details. If your attention, your flashlight, is weak or the labels are incomplete, it's harder to find that book memory later.
So a lack of focus when learning is like a poorly labeled book.
Exactly. Now consider semantic dementia, where parts of the library itself, specifically the section for word and object meanings, are damaged. Someone with this might struggle to name everyday objects, initially compensating with general terms like calling a banana fruit. This can mask dementia early on, especially in high-functioning individuals. It's like that tick of the tongue feeling, but in dementia, those memories become completely inaccessible.
That analogy distinguishes different memory and language issues. Now, what about symptom progression in Alzheimer's? Does it always start with classic memory loss?
Not necessarily. Initial symptoms depend on where the protein buildup starts. Amyloid and motivation areas can cause personality changes like increased apathy or disinterest even before memory problems. Early damage in the entorhinal cortex from tau tangles can cause an initial loss of time and spatial awareness.
So, not always the expected memory lapses. You mentioned older people remembering distant events but struggling with recent ones. Is that normal aging or a red flag?
It's important to distinguish typical age-related changes from pathological memory loss in dementia. As we age, recalling specific distant memories might become less sharp. But significant, persistent difficulty retaining new information, forgetting recent conversations, isn't normal. While dementia risk increases with age due to protein buildup and potentially slower clearance mechanisms, forgetfulness itself isn't a normal part of aging. Aging also brings wisdom and a lifetime of accumulated knowledge and connections.
That's reassuring. What can we do to prevent or delay dementia?
That's the million-dollar question. Let's talk about curiosity and engagement. You described your brother as being great at objective thinking and questioning information. That active engagement, that drive to understand, is incredibly valuable. Simply memorizing facts is less beneficial than truly understanding and connecting ideas. So does being curious help prevent or delay dementia? Absolutely. It fuels motivation to learn and engage, encourages new associations, and enhances memory encoding. That drive to get out of bed, interact, learn, contributes to a more resilient brain.
That's great. What about the default mode network? What's its role in dementia?
The default mode network is your brain state when you're not focused on a task, when your mind wanders. It's one of the first areas affected in Alzheimer's. It's distinct from areas active during focused attention. Think of Dr. House from the TV show, having breakthroughs while seemingly thinking about something else. That's the default mode network, enabling those unexpected connections.
So mind wandering has its benefits.
Indeed. Moving on to diagnosis, you asked about clinical tests like spinal fluid analysis and MRIs. How reliable are they now?
Can we confidently diagnose using these tools?
Yes, we can diagnose with much higher probability than 10, 20 years ago. However, carefully listening to the patient's history and observing symptoms is crucial. Early signs like word-finding difficulties, trouble recognizing faces, even subtle personality changes are valuable clues. Patients might attribute these to aging or stress, highlighting the need for a thorough assessment combining various information. We also see early onset Alzheimer's, with symptoms starting younger. The youngest reported case was in their early 30s, and atypical presentations like an older adult suddenly developing OCD-like behaviors or significant mood changes. These variations demonstrate the disease's complexity.
Diagnosing dementia involves more than just a memory test. Recognizing those early signs is crucial. When someone develops dementia, what exactly is lost? Is it intelligence, memory, or something else?
It's not primarily intelligence loss, although cognitive abilities decline. As we discussed, Alzheimer's can be sporadic or genetic. My research focuses on language networks, which are often significantly affected in Alzheimer's, hence the word-finding difficulties and communication challenges.
That makes sense, considering the language issues you mentioned. What about the practice of isolating individuals with dementia? What impact does that have?
Isolating them often worsens their condition. Reduced environmental stimulation and social interaction can accelerate decline. It's vital to engage with them, regardless of their cognitive impairment. We need a more supportive approach to aging and brain health. The years after 60 and 70 can still be filled with wisdom, connection, and joy. Social interaction, friendships, and enjoyable activities can potentially delay or slow down dementia progression.
Staying connected is crucial, not just for quality of life, but potentially for slowing the disease. You mentioned cognitive reserve earlier. How do we build and maintain that?
Cognitive reserve is built through lifelong learning, mental stimulation, and social connections. Equally important is understanding how your brain learns and rests best. This leads to cognitive resilience, a crucial factor with 3 key components: curiosity, agency, and social interaction.
This sounds like a solid foundation.
It is. Curiosity, that inherent drive to explore, question, and learn, we need to cultivate this from a young age. Agency, the sense of control and ability to make decisions and take initiative, activating the brain's reward system, strengthening connections, fostering confidence. And lastly, social interaction, connecting with others, stimulating our brains.
Curiosity, agency, and social interaction. A framework for promoting brain health. This ties into global brain health initiatives. What are their main goals?
The overarching goal is to promote equitable, healthy aging worldwide. This means making clear, accessible information about brain health available to everyone. We need to move beyond focusing on disease and emphasize well-being education, understanding what truly supports brain health and finding meaning and purpose in life, not just chasing achievements. Organizations like the Global Brain Health Institute, GBHI, which I'm part of, work towards this, recognizing the role of educators, mentors, and community leaders.
That's inspiring. There's a common belief that intelligent people are less likely to develop dementia. Is that true?
That's a misconception. Intelligence is multifaceted, emotional, logical, mathematical, and so on. Maybe connectivity is a better term. The more connections and pathways in your brain, built through learning and engagement, the more resilient it is to challenges, including dementia.
So it's about the network's robustness, not just raw intelligence. What's the latest in dementia and Alzheimer's research and potential treatments?
There's exciting research on deep sleep's role in clearing protein buildup. Maintaining good cardiovascular health is also crucial for brain health. Research is heavily focused on therapies targeting amyloid and tau proteins, including Alzheimer's vaccines and immunotherapies. However, the primary goal of current research is often to delay progression and manage symptoms, not find a complete cure, at least not yet. Remember the overcrowded bus analogy. If the bus, the brain, has lost many passengers, neurons, simply removing some luggage, amyloid, might not reverse the damage. Early detection and intervention are key. On a positive note, exercise, even 30-35 minutes a few times a week, supports cardiovascular health and potentially delays dementia onset. Inflammation's role in Alzheimer's is another complex area of research.
So lifestyle factors like sleep and exercise are crucial, alongside drug research. I came across information about a potential link between oral bacteria and dementia. Is there any truth to that?
That's an insightful observation. My early research explored the connection between oral bacteria and systemic health. There's growing evidence that bacteria from gum disease can disrupt waste clearance in the brain, potentially contributing to dementia.
That's a surprising connection.
It is. We also know that the APOE gene plays a role in brain waste clearance, with different versions having varying efficiency. But remember, genetic predisposition doesn't guarantee the disease. It's an increased risk, not a certainty.
Let's talk about those Alzheimer's vaccines and immunotherapies. How do they work, and what's their current status?
These vaccines and immunotherapies aim to bind to amyloid proteins and help the immune system clear them. For maximum effectiveness, they likely need to be administered very early, maybe even before symptoms, to prevent widespread protein buildup. This emphasizes the need for early diagnosis. While promising, some current immunotherapies have potential side effects like temporary brain swelling or microbleeds, possibly because they also interact with amyloid in blood vessel walls. It's a risk-benefit analysis, delaying cognitive decline versus the risk of side effects. Research is active, and there's optimism for more effective and safer treatments in the future. We might eventually see personalized risk assessments and preventative strategies.
A future of proactive risk management. Is there a connection between epilepsy and dementia?
The relationship is complex. In later stages of neurodegenerative diseases, ongoing cell death can disrupt brain signaling, potentially leading to seizures. So, epilepsy can emerge in advanced dementia. Research is investigating if epilepsy earlier in life increases dementia risk, but findings are inconclusive. Interestingly, some anti-epileptic drugs might benefit cognition in some dementia patients, possibly by reducing excessive brain activity, even without seizures. It highlights how neurodegeneration is multifaceted, affecting different brain regions and cells, leading to varied outcomes.
Everything is interconnected. We've covered research and treatments. Any quick fixes or general recommendations beyond what we discussed?
Be wary of quick fixes for something as complex as dementia. We talked about sleep, exercise, and mental engagement. Underlying health conditions matter too. Diabetes, for instance, can affect the blood-brain barrier, making the brain more vulnerable. Long-term use of certain medications, like some antihistamines that cross the blood-brain barrier, can also negatively impact cognitive function. Even acute illnesses, like infections or major surgery, can temporarily worsen cognition in those predisposed to dementia, possibly due to blood-brain barrier disruption and immune activation. Regarding diet, a balanced diet like the Mediterranean diet, rich in fruits, vegetables, whole grains, and healthy fats, is generally beneficial. And always consult your doctor and get tested before taking new supplements.
Practical advice. Focus on overall health. Be cautious of unproven claims. You mentioned optimism for dementia research. Summarize your outlook on treatment and management's future.
I am optimistic. Dementia research is rapidly advancing. I believe we'll see significant advancements in delaying onset, slowing progression, and managing symptoms within the next 15-20 years. To clarify, current vaccines are more accurately immunotherapies, likely most effective for early-stage or high-risk individuals, not as a general vaccine. COVID-19's impact on the brain is also being studied, adding complexity. These immunotherapies work by binding to amyloid and aiding its removal. While promising, with some studies showing a 20-30% slowing of decline, they're not perfect yet. More research is needed for improved efficacy and reduced side effects.
That's encouraging. Now, this might sound like a very specific question, but I was reading about the parasympathetic nervous system, the rest and digest part of our nervous system, and I wondered, could there be a connection between its activity and dementia even before cognitive decline becomes noticeable?
That's a fantastic question. It shows you're really thinking deeply about this. You're absolutely right. Even before cognitive decline is obvious, protein buildup can affect the autonomic nervous system, which includes both the sympathetic, fight or flight, and parasympathetic, rest and digest branches. And the vagus nerve, which we touched on earlier, plays a key role here. There are studies indicating that individuals with protein buildup, even without dementia symptoms, show reduced activity in both the sympathetic and parasympathetic systems. It's like their ability to switch between on and off states is impaired. Think about Parkinson's disease, where early non-motor symptoms like constipation and loss of smell are now linked to protein accumulation affecting those autonomic pathways. We definitely need more research and data collection to fully understand these connections.
That's really fascinating. It makes you wonder what other subtle signs might be out there. Another thing I was curious about was whether dementia rates vary significantly in different parts of the world, perhaps due to lifestyle or genetic factors. Do we see these kinds of geographic differences?
That's a great question, and it highlights the need for more research in specific populations. We know that there are certain regions, often referred to as blue zones or super-ager communities, where people tend to live longer and healthier lives, and researchers are studying those populations closely, looking at genetics, diet, lifestyle, even stress management techniques. However, when it comes to dementia rates specifically, the data for different regions, particularly within Turkey, are not as robust and reliable as we would like. Turkey is a diverse country with varying cultural practices and lifestyles. We need more systematic data collection to get a clearer picture. It's also fascinating to consider how factors like social interaction and opportunities for decision-making might differ between smaller rural communities and larger urban centers. Those differences could potentially impact cognitive reserve and resilience. And for women in Turkey, their roles and responsibilities are multifaceted, presenting unique challenges but also potential protective factors. It's a rich area for future research.
It really highlights how much we still have to learn. We've talked a lot about research and medical interventions, but you also emphasize the importance of well-being education. Can you elaborate on what that means and why it's so crucial?
Well-being education isn't about charity. It's about empowering individuals to understand what genuinely benefits their brain health and overall well-being. It's about internalizing those values, recognizing their connection to a healthy brain, and applying them in daily life. We need to teach children and adults how to make healthy choices, how to care for themselves, how to cultivate those pillars of cognitive resilience we discussed. It's about making sound decisions, being proactive, and recognizing that we have agency in our own lives. It's also about seeking out and learning from positive role models, those who exemplify healthy aging and share their wisdom. Podcasts like this, conversations like the one we're having, are all part of that process.
It's about taking ownership of our well-being. You mentioned the Global Brain Health Institute earlier. Can you tell us more about it, its work and mission?
The GBHI is dedicated to promoting equitable, healthy aging worldwide. It was founded by the University of California, San Francisco, and Trinity College, Dublin. Importantly, it's not just for doctors, it's a multidisciplinary effort. GBHI focuses on empowering individuals and communities to improve brain health locally.
That global, collaborative approach is powerful. We also talked about brain banks earlier. Can you explain what they are and why they're important for research?
Brain banks are repositories for brain tissue donated after death, crucial for research. Through GBHI, I had the opportunity to work with a brain bank, an experience that deepened my understanding of this field. In Turkey, there are ongoing efforts to establish more brain banks. It's a step towards advancing our knowledge. Selçuk Şenger, a prominent Turkish scientist, donated his body to science, a powerful example of contributing to future understanding. Looking even further ahead, there's the fascinating prospect of AI and digitizing the human brain. While it holds possibilities, it also has limitations. Can we truly replicate things like imagination or creativity? That remains to be seen.
Those are profound questions for the future. You also mentioned a project close to your heart, the Turquoise Project. Can you share more about it?
The name is a play on Turk, representing Turkey, and turquoise, the color. But it also holds personal significance. The project aims to promote transparency and education about dementia in Turkey. Openness is a core value, shifting the conversation away from organ donation analogies when discussing brain examination. Initially, we surveyed the public and healthcare professionals about dementia, revealing common misconceptions. We have a collaborative team from various Turkish universities working to educate the public in clear, accessible language. We even translated children's books about dementia, aiding understanding, especially around loss and grief. The project is deeply personal. It's inspired by my grandfather's experience with dementia and the journey of a close friend, Zarin, who faced the disease with remarkable grace. It's a reminder that even in the face of such challenges, there's beauty and resilience. It's about remembering those we've lost and honoring their lives.
Thank you for sharing that. It's a beautiful and important project. As we wrap up this deep dive, I'm struck by the sheer complexity of dementia and Alzheimer's, but also by the incredible progress being made in research and our understanding. For our listeners, what's one key takeaway you hope they'll carry with them?
If I could leave you with one thought, it would be this. Cherish your brain, nurture it throughout your life, embrace curiosity, stay socially connected, challenge yourself mentally, and take care of your physical health. These actions are not just about preventing disease, they're about living a richer, more fulfilling life.
That's a powerful message to end on. We've covered a lot of ground today, but there's always more to explore. We encourage you to continue researching, questioning, and engaging in this important conversation. And remember, you're not alone in this journey. Thank you for joining us for this deep dive. We'll see you next time.